section 7.2, adding and subtracting fractions. So just like in section 7.1, we extended the whole number system to include decimals by using the base 10 system, right? Because every decimal place is 10 to a negative power, or a fraction with a denominator as a power of 10. So we extended the base 10 system, our whole number system, to include decimals. So we can also extend all of the different operations to decimals. So we can now add, subtract, multiply, divide these decimals. And we can do so using the different models and algorithms that we had for our whole numbers back in chapter 3. So the first thing we're going to look at is using the model of base blocks. So we talked about how to represent decimals using base blocks in the last video. So remember that the first thing we need to do whenever we're trying to represent a decimal number using base blocks is to specify which base block will represent 1. And we said in the last video, I think it's easiest to just have the smallest place value in your problem, which is the hundredths here, be represented by a unit, which is the smallest base block that we have. So the smallest place value is represented by the smallest base block. And then the tenths here would then be represented by the next largest, which is the long. And the ones here would then be represented by a flat. And remember that if we were to extend this one more, we would get to the cube, which is like a 3-dimensional cube, which is a little bit hard to draw on paper. So oftentimes the problems we use where you have to draw it won't include that. Okay, so we've assigned which place value will correspond to each base block, but we need to write explicitly that a flat will represent 1. So we associated the flat to the ones place. So this flat will represent the value 1. And something that we always need to specify is which base block represents 1. Okay, so now, just like how we did before, in order to add numbers using base blocks, we're going to represent each of the numbers using base blocks and then combine them, regroup them, and then see what we're left with. So first, we want to look at the base block representation of 2.17. Remember that we should read this 2 and 17 hundredths. So we have 2 flats because the flats are in the ones place. We have 1 long in the tenths place and 7 units, which are in the hundredths place. And now we can represent 1.43, which is said correctly as 1 and 43 hundredths. So we have 1 in the ones place. So we have 1 flat. We have 4 in the tens place. So we have 4 tenths. Sorry, we have 4 in the tenths place. So we have 4 longs. And then lastly, we have 3 in the hundredths place. So we have 3 units. So then we combine these exactly like we did before. So one thing to notice is that we're only going to be using base 10 blocks from here on out. I know back in chapter 3, when we started talking about base blocks, we talked about things in different bases, but we extended the base 10 system to include decimals. And remember, decimals represent the different powers of 10, tenths, hundredths, thousandths, 10 thousandths, and so on. So we're only ever going to deal with decimals in base 10. You can do decimals in different bases. It's just a lot more complicated. So we're only going to deal with decimals in base 10, which means that when we regroup our base blocks, we can regroup 10 units. So we had 7 on the top, 3 on the bottom. So we regroup these 10 units into a long. And so now we have 1 long on top, 4 on the bottom, and then this one that we got through regrouping. So we have 6 longs, and we can't regroup that because we're in base 10. We need 10 to regroup. And we have 3 flats, and we can't regroup those either. So what we get is that whenever we add 2 and 17 hundredths and 1 and 43 hundredths, we get 3 flats 6 longs, and then we didn't have any units left over. So remember that the flat represents the ones. So we can write this as 2.17 plus 1.43 is 3. The flats represent the ones place, and then we have the decimal point, so that the longs represent the tenths place, and the units represent the hundredths place. So this is our answer, 3 60 hundredths. Which, remember that as we talked about in the at the very end of the section 7.1 videos, we could represent this as 3.6 because we didn't have any units, so you don't necessarily need to account for them. So this could be written as 3.6. So 3 and 6 tenths is the same thing as 3 and 60 hundredths. Okay, now let's talk about subtraction using the base blocks. Okay, so now, similarly, I'm going to do the same thing we had before, where this hundredths place is going to be represented by units. Tenths place is going to be represented by longs, and the ones place is going to be represented by flats. So just like before, we have that a flat represents the value 1. And remember now, when we do subtraction, we don't write the base block representation of both the numbers. We just write the base block representation of the first number. So we are going to represent 3.61, which is 3 and 61 hundredths. So we have 3 flats to represent the value 3. We have 6 longs to represent the 6 in the tenths place. And lastly, we have 1 unit to represent the 1 in the hundredths place. And remember, when we use base blocks, now we're going to take things away. So we want to take away 2 units first. Well, we don't have 2 units. So we don't have 2 units to take away. So we're going to regroup, where now this 1 long becomes 10 units because we're in base 10. So now we can take away 2 units. So I'm going to have the takeaway be red and the regrouping be blue. So we're going to take away our original unit and one of these others we got here from regrouping. Okay, so we took away 2 units. So now we want to take away 7 longs. Well, we only have 1, 2, 3, 4, 5 left. So again, we're going to have to regroup one of these flats into 10 longs. Okay, so now we have 10 longs, and we need to take away 7 longs. So we can take away our original 5, and then 2 from the ones that we added. And then we want to take away 1 flat. So we took away, I'm just going to write it here in red. So we took away 2 units, 7 longs, and 1 flat. So those are the things that we took away in red. In the blue, like I said, the blue, I can draw arrows just to make it a little bit more clear, is how we represented regrouping a long into units and a flat into longs. So we see what we have left. So 3, well, we have, what do we have left? We have 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Left, we have 1, 2, 3, 4, 5, 6, 7, 8 longs left. And we only have 1 flat left. So that tells us that 3.61, 3 and 61 hundredths. And when we take away 1.72, which is 1 and 72 hundredths, we get 1 flat, 8 longs, 9 units. So 1 and 89 hundredths, 1.89. maybe write that a little bit. Okay, so that is boxes. That is what, yeah, let me fix the box up here to just box the whole thing. Okay, so this is how you add and subtract using base blocks. So it's a really similar process to how we added and subtracted with using base blocks in chapter 3. So yeah, it's a really similar process. It's really simple. The only difference is you have to decide which base block represents one and adjust accordingly, but the actual process using the base blocks is the exact same. Okay, so that's all for adding and subtracting decimals using base blocks, and that's all for this video.